Hey everyone, welcome to another BTM screencast. Today we're going to be going over gable, shed, and flat roofs. So let's talk about the components of a common rafter. This is what you're going to be cutting. So we're going to have the ridge plumb cut, the bird's mouth, C cut or heel cut, rafter length, line length, and theoretical length, fascia plumb line, soffit level line, and fascia plumb cut, as well as a soffit cut. So here we have a good example. These are going to be the walls that you're going to have framed. These are part of the knee walls for your performance assessment. When you come up, this is where we're going to look at the rafter length. Up here, we have our ridge, which is the center of your roof. Down here, this is your bird's mouth. And here we have plumb cut or a fascia cut. Common rafter layout. All rafters follow a similar process for layout. Once the layout is completed and checked, it becomes the pattern for the remaining rafters. So you have to lay out one. After you lay out one, and that one works well, you could take it, copy it, and use it for the other ones. Just make sure that you have that listed as the one that you're using as your template. So here's a typical common rafter layout. So up top, this is the ridge plumb cut, so this will go right into the ridge, which is the center of your roof line. 2 is the shortening for the ridge length, so there's the point there to the point there. The determined line length goes from here all the way down. The seat plumb cut line, you can see at number 4 is right here, and the reason that we're having that is for number 5, which is the cut level line. So this is why it's called a bird's mouth if you look at it. For number 6, that is the determined tail length, so this will be the overhang past your wall. Number 7 is the cut for your fascia, and this is like the finished side of the end of your roof. And number 8 is the soffit cut line. So if you look at these are very similar, and the layout and everything else is very similar as well. So here we have using the different squares. We're going to go over this in more detail when you're ready to do this, and then I'll show you either how to use the large framing square or also the speed square to lay out your common rafters. So here's the steps that we can take to do this. Take your time, look this over. This can get confusing at times, but that's why we're going to be practicing it in lab. So there's 2 different ways that we can figure out the length of your common rafter. The first is a step-off method. So in this case, we'll be using the framing square, and then we can actually take it and step it off. It's called stepping off because it looks like steps. The calculation method will actually take a tape measure, go and figure out what the theoretical length is, and then go that way with it. So here's an example of the step-off method, and you can see where you can lay out everything here. This lets us know the roof that we're doing. We come over here, and then we'll go over how to lay all of this out. And then you take it, and then you just step off each one until you get to the end. And that's it. You repeat it until you run out. The calculation method. So again, we can pull this with a tape measure and figure it out. So we're just going, what this one is, this one, and we keep on going down. And again, we're going to be going over this before you go and lay out your rafters. And this is kind of what it looks like. So before, this is our ridge, so you can see that the center of that, and then remember that we have to subtract 3/4 of an inch because our ridge is 1.5 inches, and then our line length goes from here all the way down. So here's an example of the rafter length. We'll be doing these with our daily math problems. So if you want to use this one, feel free. We'll be doing more. The seat cut layout, so a combination of a level cut and a plumb cut. Seat level line is not a precise measurement. It must only be perpendicular to the plumb line and not cut too deeply. Sometimes level line is extended to allow for sheathing. And again, this sounds a little confusing, but once we lay it out and you get into it, it's going to make a lot more sense. So here we have with the frame square layout, stair gauges, which I have sitting on my desk. We'll use that, and then you'll be able to lay out all of your cuts this way. The speed square layout, this is another way that we're going to be doing it. And then here we go with the plumb lines, and I will show you how to line these up. There's specific numbers on here also. The seat level line is extended towards the tail and a new plumb line is drawn. So here we have our plumb line, and this is extended, so we incorporate the sheathing into it. Common rafter tails, so a tail cut, that's the stepping off one, or we can calculate the overhang. We're going to be doing both of these. You have your plumb cut and your soffit cut. So here we have what our measured overhang is, so from this plumb line to this plumb line, but you can see that we're going to cut this off, so then we're able to attach our soffit and then our fascia right here. Here's another example of that. So this is after the cut is made. So you can see the cut is made to keep the bottom edge of the rafter above the fascia, but low enough to give and support it. Here we go. So if you have a wide rafter, you could see that we're going to have to extend this up and actually cut this out to make sure that we have the finish that we need here. So here's the calculation method. There's a lot going on here. I'm not going to have you read this, and it would make more sense for me to go over this once you're doing your performance assessment and we have that rafter in front of us and we're able to do that rather than trying to figure out what's going on with all of these steps. Now, this is a good reference. As you're doing this, it wouldn't be a bad idea to have this pulled up on your Chromebook and then use this to go back and forth after we go over it. So some additional thoughts. Engineered I-joists may be used for rafters. A ridge board is laid out the same as wall plates. Remember what your centers are. Ridge board ends may overhang a gable end, and that goes for the type of roof. So here we have different fastening methods and what that looks like. Take a look at that. And then here we have our ridge sticking out and extending the gable end out. Erecting the gable roof frame. So most efficiently done by 3 workers. Place the plywood on ceiling joists to serve as a safe work surface. Now, you'll be doing knee walls, so this is going to be a little different. You're not going to be on too much of an elevated surface, but enough. Nail 2 rafters to the ridge board. Raise it, nail at the bird's mouth, and temporarily brace. So if we do this on one end, it'll work fine. Nail rafters in pairs, watching to keep the ridge board straight. So I will have you guys run a line from end to end, making sure that it's going to be straight, because sometimes the ridge boards won't be straight, so we need to make them straight. And here's an example of what can be done. And again, keep this as a reference. We'll go over it and we'll get more in depth when you're actually doing this. The gable roof frame. So you're going to need collar ties, rake rafters, and lookouts. So you can see we have our lookouts. They're notched into the second rafter right here, and that's to help support. and that's where we have the notched rafters. The rafter with lookouts is supported by the gable end wall, so you could see that they're here, and they're supported right here. So these two styles are slightly different, but they accomplish the same thing. Installing gable studs. So when you lay out the gable studs, the end wall plate is laid out for the location of the gable studs. To find the stud length, you cut and fit, right? Because some of them can be different and they'll change. So you can see here, this is the double top plate, so this will be at the top of your knee wall. Here's your rafter, and then your gable studs will be cut to fit. So here's a nice one where they take the rafter kind of away, and then you can see the cut for your gable studs will have the thickness of your rafter removed, and then this is cut at the same angle as your rafter. So here you can use this to find the length and angle cut. So if you have your stud, hold it up so it's plumb, and then you can mark it accordingly, and then that'll get you your angle and your length at the same time. And again, here we have this with measuring your studs out. There's a lot going on here. So again, we're going to go over this in more detail when we're doing the performance assessment. I don't expect you to come through here and be able to bang all of this out, right? It's going to take a while. But again, pull this up. It's a nice reference to have once we get to that point and you're working on this assessment. Shed roof framing. This one's a little easier. Shed roofs open only one direction, so you won't have that ridge in the center. They're relatively easy to frame. They're made of all rafters that are common, and the layout for a shed rafter begins at one end and progresses to the other end. So you can see that we have the freestanding shed roof. Now, the only thing that makes this maybe a little bit more complicated is we're going to have two birds' mouths, right? Other than that, everything's the same. You also have the option to do the attached shed roof, and when you do that, you can see that you're going to have a ridge board and attach it to an existing wall. And again, here's a layout for this. For your performance assessment, you'll be doing a gable roof, but this is a nice reference in case you want to do it. We can make that happen. So if a shed roof is something that you want to do instead of a gable roof, let me know, and we'll just build everything accordingly. So in conclusion, gable roofs have common rafters which have many component names, and you can see that they get used interchangeably, plumb cuts, C cuts. So be ready to throw out a bunch of them. Common rafter layout requires many measurements and several cuts. If you don't get it right the first time, that's okay. We're going to do the practice layouts. After you get done with the practice layouts and that's satisfactory, then you'll lay out your actual rafters. So even if you get it wrong once, twice, 20 times, that's okay because you're going to practice it until you get it right. After you get it right, then we'll focus on getting it cut, and then we'll see if it fits, and then if it does, that's your template. Rafter length is best determined by the calculation method. Erecting a gable roof is done one member at a time. And also remember that engineered I-joists may be used for rafters. We're going to be using 2x6s, so just something to be aware of. Gable ends are framed with studs, and again, we'll go over this when it's time in the performance assessment after your roof is done. That's it. If you have any questions, let me know. If not, see you next time.